Hi, I'm Betsy Webb, Superintendent of the Bangor School Department, and today I have with me students from Bangor High School that are the state champions for the Wind Blade Challenge. I'd like to start by having you introduce yourselves, and if you could share with the community what class you're in, and maybe you're the rising class at this time of the year, right? So we'll start with you, Sydney.
All right, so my name is Sydney McDonald, and I'm a rising senior. I'm also a rising senior at Payne.
I'm Morgan Jones, and I'm also a rising senior.
Feels pretty good to be a rising senior.
Yeah.
Yes, exactly. So you were in this contest recently at the University of Maine. I believe it is at the Composites Center. Can you tell us a little bit about this? What was this challenge that you had to do, and how did you prepare, and how did you work as a team?
There were 33 teams from around Maine who all came to the University of Maine to test the wind blades they had built over probably a couple month process. And it was a really fun event. We all got together and did presentations and tested our wind blades in front of a panel of judges.
So how do you make a wind blade?
So the ideal of this challenge, or the idea of this challenge, is basically to get a wind blade that can generate the most amount of energy, because of course wind energy is extremely important in the coming age as we're trying to move away from fossil fuels and the like. And so the goal is to design a wind blade that can effectively capture the wind energy that's being put towards it, like a wind, and move at a high velocity, which generates enough voltage for the current that we're using to power cars, houses, or anything else. So what we did specifically was we analyzed past designs and everything that has worked and everything that hasn't worked. And we took the things that have gone really well and then we adjusted them to fit our own design and added our own little quirks and things to make sure that it was our own design and make sure that it could do better than what has done well in the past.
Oh, that's awesome. I love how you have the research of what worked well and what didn't work, because that's really what creating things are all about.
Yes.
And you can see that here. This is a prototype we used, and this minus the cardboard piece is the design from last year.
Okay.
So that was our process. We built onto last year's design.
So were you the same team together last year?
No.
But you looked at Bangor's design last
Yes.
year. Gotcha.
Last year it was a group of seniors who did this design here, and so since they did extremely well, we decided to use this design, add our own addition, which you can see here is the cardboard, and then of course we adjusted it for the final design, but use this to figure out whether or not our ideas would work better than what had worked in the past.
Okay, so theirs last year did not have this element that's curved. It reminds me of looking at a ceiling fan.
Yeah. Yes.
Yeah.
Because some will have a very square, like almost like a paddle look, where some have a design like this. And what you were looking for was that curve to make it have more energy.
Yeah, it would reduce the drag of the wind. Yeah.
And capture more.
Yeah.
Because,
Capture.
yeah, in the space between the hub, which is a circular piece, and the blade itself, there's a lot of area where wind is flowing past the blade, but it's not being used, it's not being harnessed. And so, although we have to avoid adding too much surface area, as that adds more push against it, and that creates more drag, we wanted to add this to capture some of that wind energy that's being lost and try to do better than previous blades, which often just cut off straight here.
Right. Now, how did you guys select being on this team? How did you decide that 3 females were going to be the wind blade team?
Well, we are the 3 juniors in this STEM class for 2017. So it was just the 3 of us in our class, and we wanted to do this challenge.
We're the only ones left, and
Yeah.
so we kind of bonded together.
Wonderful.
It was really fun experience.
Yeah.
So you said 33 teams from all around the state.
Yes, there were a few schools that had multiple teams.
Okay.
There were quite a few teams from Lewiston, Orono, and Bangor.
And Bangor had a few teams as
Yeah.
well. We had other teams
We had
there.
6.
Oh, we had 6
Yeah.
teams there. Okay, great. So 18 of our students were there.
Some of the teams had 4 teammates, I think.
Okay.
And they were freshmen.
And they were freshmen.
Yeah.
Wonderful. And are they also in the STEM Academy?
Yes.
Nice. Nice.
All of the competitors from Bangor High School were in the STEM Academy.
Great. So in thinking about when you get to the challenge, you had your prototype, you developed your actual wind blade. You talked about you had to do presentations. Is that like a formal speaking part and kind of showing the engineering and the creation and design? And then do you have a challenge where you actually see which one captures the most
Yes.
wind and it gets the most electricity?
Yes, we've set it up on a testing platform in the middle of the Composite Center, and we had a display of fans, and we actually recorded how much voltage it was being produced, and ours was the best out of the competition at 30 volts.
At 30 volts.
At the highest.
Oh
yes.
wow.
And
What was the next one down?
There was one that was pretty close, 30 volts, but the competition is designed to add resistance as you go, and ours was 30 volts, and our minimum was 13, and most others was around 7. So
yeah, so how it works is you have, originally you just had the wind blade with no resistance added whatsoever. And so they take the highest voltage that it generates at that point, and then you add on this little lighthouse with 3 different levels. And so that provides the resistance, is that you have to light up each of the lights on each level. And so they record 1 voltage for each level that you're at, each level of resistance, and add them all together to get the total. And so that's how they kind of figure out who had the best energy output before doing the presentations.
And
Is there like hooting and hollering when you get that?
yes,
Yeah.
there was a lot of applause.
That's nice.
Yes.
That's awesome. So, did you do any level of pre-testing with just the Bangor team? So, did you all just do your own work and get there that day to see how it went?
We did do some testing beforehand. Unfortunately, we couldn't actually make this blade until just a couple of days before. So we tried to go through the engineering design process and test this prototype and some other samples to see the best results that we could have.
Okay. Because that must create, I don't know, a little bit of excitement before you even go to the big day.
Yes,
Yeah.
definitely.
Now, what is this made of?
So it's made out of foam. They're actually, it's carved out of the foam. We didn't hand sculpt them, so to say. So they are exactly the same because there's always human error whenever you do it by hand. And so we brought them to be carved out. And so we did it through a computer program where we first captured the blade. So this is why we have this, where we took pictures of it and captured the blade. We took pictures all around it, and then we put it into a 3D Catch program, which stitched all the pictures together so that we could get a 3D model. And then we brought it to carved out, and then we added also our own piece addition, which you can see here, except it's a little different with the cardboard.
And so we got it. We had it carved out by the 3D machine, and then it was a foam piece, and we went and got it covered in fiberglass.
That's what I thought. I thought I could see fiberglass.
Yeah.
Okay, good.
Yeah, you had it covered in fiberglass and injected a resin into it, which is the process that professional engineers who work in this field use.
I think one of the best things about our project is that it most closely mimics the way that real wind blades or real engineers work, and that, one, we didn't simply do it all by hand, as I think every other team did. We were the only ones to use this programming to ensure that these are equal, to make sure that it's the most efficient and the least time-consuming, and it requires the least manual labor. And then that compiled with just how well the infusion process went.
That unique aspect of our project definitely gave us an advantage in the competition.
And an advantage in your future. That's what I love, is when we're able to provide opportunities for students to actually practice real engineering, real science, real math, whatever it is. Because, well, for example, what is the 3D capturing software that you use?
It's called 123D Catch.
Okay.
Yes, and then the actual design software that we use to edit that 3D model is called Mesh Mixer.
Okay. And those are probably software packages that are used in industry.
Yes.
I would imagine,
Yeah, we talked. The people we talked to said that they do use those
Yeah,
programs.
we talked to an engineer at the University of Maine to get some advice, and that's what he advised us.
And I just think that's amazing, because then when you face something like that in your post-secondary learning, you've already had that exposure.
Mm-hmm.
No question. So why yellow?
We wanted to
I
stand
question
out.
that too.
But it does stand out. I love that, because your prototype's a little. Yes, that's great. So you said that this right here, why don't we look at it a little bit more closely, is you were trying to replicate what it was really like when you did the competition. So I know you were starting to tell me about there were fans set up, and you want to take me through how does this differ from what actually was happening at the competition?
So in the actual room that we did it in, it was this giant composite center. It's a very large room. They have a set of 3 fans that are slightly smaller than the ones that we used, but also stronger.
Okay.
And so when we were testing, actually, we got significantly lower voltages, like around 20 volts at the maximum, because we were using a lower wind velocity.
Right.
So that was quite a nice surprise when we saw it.
Yeah.
Yes, great. And so we that was one difference between our testing and what it was actually like. And then also we had it at this level, like the platform was very similar to what you see here, just better in appearance, and it actually secures the wind blade on.
Okay.
Whereas at the testing center, it was higher up, it was more advanced, it was professional equipment that was used in that center.
But the equipment we use here was pretty similar to the equipment that you would really use in this example.
And that might be another example of why you did so well, because it
Yeah.
is so close.
Mm-hmm.
I know that your teacher, Mr. John Cangelosi, we'll have him come over, was coaching the team from last year, so saw some of these situations of what it was like there. And I'd like to have him talk a little bit about what did we do differently this year in order to have our teams do so well at the competition.
Well, I think the big difference with this group was I wanted them to do very little sanding and cutting, and use software tools available and engineering tools that are available to them. One flaw with other blades was, even if the students did an incredible job of shaping the blades, they weren't exact. So when the blades began to spin very fast, a lot of energy was transferred to the wobbling of the table, or other effects that wasn't going directly into the voltage. So the way these guys did it, with having the model 3D printed, it had made an incredible difference with the blade, and just how cleanly it turned and how balanced it was. So that was one thing that was very nice. It was also very nice not to generate a whole bunch of dust and, use saws, and they did do some sanding, but it was very little compared to what we've done in previous years.
Sure. Well, it just seems like to have more of the focus on the engineering part of it is what the competition is really about. Certainly there's value in sawdust and all of that, but that's not what the main intent was here.
Right.
So that's fantastic. Any other things that you'd like to share about how they work together as team members and what you saw over the month that they were designing this and preparing this? Because I think one thing that we're really trying to do in Bangor is to have students practice science so they understand it better. So would you like to address that?
Yeah, so it was really nice seeing them work as a team. So I had never gone through this process before with using just the software. When we had entered before, we had done it just by eye. So it was really interesting seeing how much time had to be put into the capture. So first of all, they wanted to build on existing designs, and that was a really good approach, because they took designs that tested well, and then captured those designs, adjusted them. But when they did that as a team, they all picked different sections of the blade to work on, and it was very nice how the group kind of divided the work, and so that they could get it done as quickly as possible.
I'm going to switch over to the STEM Academy. If someone were thinking about the STEM Academy, a student maybe is an 8th grader thinking about coming to Bangor High, or maybe they're a sophomore or a freshman, rising sophomore, what would you say to them about this experience?
Well, I would definitely say that is a unique one, and that I am very grateful that I decided to do it, because it is very hands-on and interactive, and that if you're in any way interested in science or engineering, that I would definitely try it out and do it. And because there's only one way you can figure out if you like it, and that's by doing it. And so it's almost easier to do it now than if you're in college and wondering if this is something you're interested in. And that it's because it is so hands-on. That's what I love about it, and that it's a phenomenal program, and I feel like I've learned a lot of academic skills, but also just life skills in the program.
Yeah, and the opportunities awarded you by being in this program are incredible. Like we get to work in labs at the University of Maine and have all these other great experiences and opportunities that other students don't, just because we're in this program. So that's definitely one huge benefit.
And there's so many great mentors too that we have at the university and here at the school as well.
Yeah.
It's helped us a lot.
I think a big thing that we all learned is that the work is worth it. Like this
Yeah.
program is incredibly rigorous. Like throughout the past 3 years, one of the big things I think we've all bonded over is how incredibly difficult the program is. But because you're doing so many different things, you're at a college level, you're doing these internships, and everything that you do is kind of above the bar. Whereas in a normal science class, yes, you're doing the work, yes, you're learning, but this is an entirely different level, and it not only prepares you for the real world, but it just puts you in a better mindset to actually get your schoolwork done as a whole, and that you kind of hold yourself to a different standard.
I can't tell you how rewarding that is to listen to, because when we created the STEM Academy, our overarching goal was to have a better retention rate at the post-secondary level in the STEM field. And we know that these, the jobs in Maine that go unfilled are often STEM field jobs. And so we wanted to have a program that would better prepare students for those jobs if they wanted them. Now, we've had students go through STEM and decide it's not for them, and then they go on to something else, but they have shared with us that they still feel they were well prepared for that next level. So it's really nice to hear you say, in combination and in chorus here, that it challenges you, but you have great mentors and you have great people around you that prepare you for the next step, whatever that future may be.
Yeah, Mr. Cangelosi and Mr. James and all of the other faculty have really done an amazing job teaching us to value everything that we do in both STEM and other kind of realms of study. And I don't think we would be here at all if not for them. We would not be doing nearly as well.
Well, that's a perfect way to say thank you, Mr. Cangelosi, for your great leadership, and all the other teachers, and all of you. We're extremely proud of you, and congratulations.
Thank you.
Thank you.